Welcome to all. In the previous session, we have discussed about HDB3 coding. In this section, we discuss about BNZS, that is binary with N0 substitution signaling. A class of line codes similar to HDBN is the binary with N0 substitution or BNZS code. In previous section, the HDB3 where n is equals to 3, we are going to substitute a special code for a group of 4 zeros. The special code, it may be B00V or 000V, where alphabet B and V are equals to 1, where B bit is going to follow the bipolar rule and V bit is going to violate that rule. Similarly, in this BNZS, where if n zeros occur in succession, they are replaced by one of the two special sequences containing some ones to increase timing content. There are deliberate bipolar violations just as in HDBN. Here, the two cases what we are going to discuss in BNZS are B6ZS, that means n is equals to 6. Another signaling, it is B3ZS, where n equals to 3. In B6ZS code uses a string of 6 zeros is replaced with a special code that is 0VB 0VB. That means a group of 6 zeros in the given binary stream is always replaced by 0VB 0VB, a special code in B6ZS signal. Here in B3ZS code is slightly more complex than the others in that either B0V or 00V is used. Means we have two options. In B3ZS, we may replace a group of 3 zeros by B0V or 00V with conditions. The choice being made so that the number of B pulses between consecutive V pulses is odd in B3ZS code. So comparing B6ZS and B3ZS, B6ZS is simple, but B3ZS is a little more complex. The application of B3ZS is widely used in the digital signaling 3, that is named as DS3 signaling, and also in a long distance 4 LD4 coaxial transmission systems. Application of B6ZS is used in DS2, that is digital signal to signal, and also in bipolar violation detection. Look at an example. To construct a binary sequence 01 00 00 00 01 0 11 in different formats. So as we know, the bipolar RZ, Manchester and HDB3, B6ZS, B3ZS. So we are going to create signals for a given binary sequence using these 5 formats. Look at this bipolar RZ. In bipolar RZ, the 0 bit is having 0 amplitude and bit 1 is having both amplitudes plus A and minus A for alternative ones, plus A and minus A amplitudes for alternate ones, and the width of amplitude is always half of the width of the signal. Hence, if you observe in this sample, the 0 bit is 0 amplitude, then bit 1, the first bit, we are going to have the amplitude plus A only for half of width of the pulse. The next half is going to be returned to 0. Next, all zeros are having amplitudes 0. The next bit is 1, which is the alternate amplitude. The previous one had plus A and next one is going to have minus A amplitude. The next bit is 0, its amplitude is 0. The next followed by 0, the next bit is 1. The previous amplitude of previous one is minus A. The present one is going to have plus A amplitude. Similarly, the next A is going to have the alternate amplitude, that is minus A. So this is the construction of binary sequence in bipolar RZ. Next, how to construct same binary sequence in Manchester. So in Manchester, 0 bit is having minus A and plus A amplitudes, minus A and plus A amplitudes for the duration of half of the pulse width. So if you look at this one, the 0 is having, it is going to begin from minus A amplitude for the half of the pulse width, and the remaining half is going to be a plus A amplitude. And in Manchester, both 0 and 1 are opposite to each other. So 0 is going to begin from minus A and at plus A. The 1 bit is going to begin from plus A for half pulse width, and it is going to end at minus A for remaining half pulse width. Similarly, if you draw the next 0, it is minus A plus A plus A continues for all zeros. When the 1 comes, it is always begin from plus A and at minus A. Next, the next construction, the format is HDB3. So in HDB3, as per the discussion, we may use B00V or 00V. So here we are going to choose 00V for a group of 4 zeros. So the given sequence is 0, 1, 0, 0, 0, 0, 0, 0, 0. Means a group of 7 zeros. 1, 0, 1, 1. Now, the first bit 0 remains the bipolar rule, that is 0 amplitude. The 1 is going to have plus A for half pulse width, and remaining it is 0 amplitude. Next, we are going to observe a group of 4 zeros. So as per the rule of HDB3, it may be replaced by B00V or 000V. We may choose anyone. For in this case, we have selected 000V. So the replacement of 4 zeros is 000V. So if you draw the signal for the special code, 0 will be 0 amplitude, 1 will be 0, next 0 will be 0 amplitude, the next 0 will be 0 amplitude. The V bit is equals to 1, hence we need to draw this one as plus A or minus A based on previous one condition. So previous one has the amplitude plus A. According to bipolar, the next one should be drawn minus A amplitude. Because of this V, that is violent bit, is going to break the rule of bipolar. Hence, instead of drawing minus A, we are going to draw this one as a plus A. Next, continue. We are going to have only 3 group of zeros, so it is not under HDB3 condition. So leave it as it is. So 0 will be 0, next 0 will be 0 amplitude, next 0 will be 0 amplitude, 1. We need to draw according to previous condition. So the previous amplitude of the binary bit 1, that is violent, it is plus A, hence we are going to draw according to bipolar, it should be minus A. So the next bit is 0, 0 amplitude, the next bit is 1. Compared to previous, the previous one was minus A, the present it should be plus A. Next plus A, it should be minus A for next one. So this is the construction of given binary sequence in HDB3. Now the main concept it is about today's section, it is B6ZS. So we are going to concentrate. The special code must be applied for a group of 6 continuous zeros. So here the special code is 0VB, 0VB. So the remaining bits will be as per the bipolar. So first bit 0, 0 amplitude, 1 plus A amplitude. So the group of 6 zeros, it is replaced by 6 zeros, it is replaced by bit 0VB, 0VB. Now go put the construction as per the bipolar rule. 0, 0 amplitude, V is the violent bit, is equal to 1. So the previous one is plus A, hence the violation is to be plus A only. Next bit is B, which is equal to 1. So 1 means it is having, compared to previous amplitude of 1 is plus A, so next one should be minus A. Next one is 0, 0 amplitude. The next bit is V, that is violation of the bipolar, even though it is 1. So here the previous one is having minus A, hence this one is also minus A. Next come to the next bit, that is B, which is equal to 1. The 1 will be replaced by comparing previous amplitude. Previous amplitude is minus A, so the present one should be drawn using plus A amplitude. Move towards the next bit, it is 0, 0 amplitude, 1. Comparing previous, it should be minus A amplitude. The next bit, it is 0. Then the last two bits are 1, 1. They are going to have amplitudes plus A and minus A amplitudes respectively. This is the coding of B6ZS. The last different format we are going to discuss it is B3ZS. So B3ZS we have chosen for given sequence, it is the first 3 bits. Here it is we are going to observe first 3 zeros group, then another one it is the second. So this is second 30 group. Now in B3ZS we may choose P0V or 00V combinations. So based on the condition, the B bit must be odd, where V must be even in the group. Now for uh, individual bits we may draw. 0 will be 0 as per bipolar, 1 will be plus amplitude. Next, these first three bits we have chosen B0V combination. So B0V, B means 1, which is going to follow the bipolar rule, hence the previous bipolar is having 1 or positive amplitude. The next one is must be negative amplitude. Next 0, 0 amplitude. V, which is going to violate the bipolar rule, hence the previous bit is having minus a amplitude, the present V it should be same, that is minus a amplitude. Next combination, once again we are going to observe second set of three zeros. In this second set of three zeros, if I use B0V, if I use B0V, so we are going to get even number of B bits, but the rule is going to tell odd number of B's must be there, so we are not going to choose this case. Then so we need to choose this one, that is 00V combination. So as per 00V combination, the first 0 will be 0 amplitude, next 0 will be 0 amplitude, and V is once again the violent bit. So violent bit means the previous one is having minus a amplitude, hence the present V is also minus a amplitude. Moving to the remaining bits of the given sequence, it is 0, 0 amplitude, 1. The previous amplitude is minus a, so the present one should be plus e. Next is 0, next is 1, 1, so it is having minus a and plus a constructions. So this is an example and discussion about B6ZS, B3ZS, as well as the given sequence is an example for the construction of HDB3 as well as Bipolar RZ and Manchester. So this is the line coding concept using different formats. So we are going to end up this session. Thank you.